Thank you. Good morning and happy Canada Day on all of you. Yay, eh? So it's quite appropriate that we should have a keynote speaker from Canada today. We have Dr. Phil Winne, who's earned his doctorate from Stanford, but thought better of it and came back to Canada to be Professor of Educational Psychology at Simon Fraser University, that's in Vancouver, British Columbia. Dr. Winne is a Canada Research Chair in Self-Regulated Learning and Learning Technologies. And for those who don't know, the Canada Research Chair is one of the highest academic honors in Canada. They're positions held for 7 years and renewable. And Dr. Winne has had held his chair since 2002 and was renewed in 2009. And the universities are very happy to have this because along with this comes $200,000 annually to the university where the chairs are held. Dr. Winne's research interests are in self-regulated learning, but obviously from today's topic, metacognition, motivation, study tactics and learning strategies, adapted software for researching and promoting self-regulated learning. And among his recent awards, he holds a 5-year SHRC grant, that's Social Science and Humanities Research Council grant, on tools and methods to help learners self-regulate learning and increase learning success. Dr. Winne has an impressive publication record with recent publications in Metacognition and Learning, Journal of Educational Data Mining, Learning and Instruction, just to name a few, and as well as 5 books. And because we're at a Summer Institute of Analytics, you'll also want to know that he has an H index of 50 and an I-10 index, a new one, with a number of publications with at least 10 citations of 85. So please join me in welcoming Dr. Winne to talk to us today about learning analytics for learning science when N equals M.
Thank you, Caroline. Caroline, was this working? Yes. Caroline was introducing my twin. I'm the lesser member of the family. So I want to talk about learning analytics for self-regulated learning today. When N equals me, I'm going to use the personal pronoun throughout the presentation. And for those of you who were here at the public event last night, I'll be using a couple of slides so you can get just a couple of winks in while you're doing that. I always like to learn from Pierre, and so I thought I'd show you something about my location. 2 of the really important places, to me anyway, at Simon Fraser University. Sadly, I don't have money for a postdoc despite this amount that Caroline was mentioning. The university eats that up in my salary and other things. And how did Canada do? Let me just go back to that for everyone else. Okay, thanks to all the funders, the obligatory slide. Sadly, none of them are here to realize that I'm thanking them, but that's that. So, I think you'll like this. So this sets a tone for the talk I want to give today, because what happens is that learners have very little information on which they can base their judgments about how they learn. They don't keep a lab notebook. They don't have a record of what they studied or how they studied, with the exception of, in the paper-based world, the highlights they make or the things that they preserve electronically. And surprisingly, they have very poor memories for what they do. So I want to try to overcome this opinionated perspective that learners have about how they study. So as I said last night, my presentation style is a little bit different than many others. I like to let you read and me talk less. That means the slides are a little bit more useful subsequently, and you don't have to listen to my scratchy voice. This is quite an interesting thought about the way in which we're wasting data by simply not capturing it and applying learning analytics to it. So here's what I want to talk about today. And I'll be showing a couple of slides about software we developed called NStudy, which is designed as a kind of super online annotation system to record, as best as we can manage it, absolutely everything that's observable about what learners are doing when they study online. And I'm going to be emphasizing this notion about me. So I've italicized the word productive next to self-regulated learning, and I do this because everybody is quite constantly self-regulating what they do. But unfortunately, not all of the ways in which we self-regulate our activities are productive. And the key is finding what actually works for people when they're engaged in examining what they're doing and trying to figure out how they can make it more satisfying for them. So let's look at a first issue I want to take up about traditional learning science. The point of this slide is that what comes out of classical studies in learning science and educational psychology is that they don't speak directly to me. Here are ways in which what goes on in classical RCTs differs dramatically from what I experience as a learner. So every one of the items that are listed in the far right column differentiate me from the classic RCT. I have a profile of moderator variables that causally affect me that are absolutely ignored in the mean that is used in determining whether an intervention has an effect. This may surprise some who didn't see it last night. So I put the citation here because I think this is a really remarkable piece. I'm a little sad that they beat me to it. I've been working on something like this for about a year, but they did a better job than I was doing. The point of this is, even if you replicate an experiment that was done, a perfectly designed, true experiment, when you try to generalize it to a second occasion of that experiment, using the same sample, you get a replication interval as wide as this. And when you try to extend the sample that you're replicating to me, given all those factors that were washed out in the preceding table, there's very little chance that I'm going to have a predictable result in experiencing that intervention. It's risky for me. It's also risky for everybody else. I want to try to turn that to our advantage later. So here's the statement about I'm not the average. Plus a bunch of other issues that matter when you try to use experimental findings from RCTs to give a recommendation to a single person. The last bullet point about named moderators and the population is important because when you name a population, what you're doing is identifying variables that are supposed to fix the values of the two parameters of a normal distribution, the mean and the variance. If you're naming factors that don't really matter, you have what in path analysis or structural equation modeling is called a misspecified model. And generalizing from a misspecified model is really hazardous. We have little information about whether the factors that are often used to name populations really matter. One of my favorite examples, for a different reason than you might think, is sex. According to the literature on human aptitudes, there's really only about one major aptitude that differentiates males from females in academic activities. It's a particular form of paper folding, spatial ability. For all intents and purposes, sex doesn't matter in most of the things that we do. And why then are we required by the American Psychological Association publication manual to always identify sex as an important moderator variable? The same is true for lots of other things, as I showed in that exchange with Dr. R. Square. So I'm a third-year student, I'm mature, etc., etc. Do those things really matter? We don't know. They're not tested in the studies. We just make declarations about what the population moderator variables are. So here's a list of some common challenges if I do try to generalize from a particular RCT or a meta-analysis. The point of all of this being that we're on soft ground in making an extension from a study to me. We shouldn't throw out these studies. They're useful for testing theoretical ideas in the first place. But moving from them to recommendations for individual people is really chancy. So what I hope learning analytics can accomplish is becoming less dictatorial and authoritative, and more engaging and open with learners. And what I want to try to do today is suggest one path we can follow to do that. Here's what Solar says about learning analytics. So at the Learning Sciences Conference last week, I heard this quote, raw data is an oxymoron. If you think about it, there is a collection of theoretical background whenever we design an instrument, whether it's a microscope, which depends on views about the ways in which light is refracted through a lens. Pick your instrument. Similarly, when we make interpretations about variables, again, I'll go to the notion of sex. Today, we refer to that as gender rather than sex. Gender is a socio-cultural construct, yet what do I know about you? Male, female. I don't know anything about your gender, but I'm required to pretty much use that word to be politically correct. Our raw data are always built up from a foundation of assumptions and the limits and affordances of the instruments that we use. And we need to keep that in mind, I think, as we try to realize that when we define data and just construct measurements to gather it, we're enforcing some ideas about our understandings of how those instruments work and what we're operationally defining as our data. So here's a quick triad of exchanges between me as an operator on information and what happens mentally inside my mind as I'm working. So how do I study? Well, these are the things that in my language I'm doing. If you ask me what I'm doing in an online learning environment, this is how I'll talk to you. Now the map I'm referring to here is the notion of a knowledge or a concept map that many of you have seen pictures of, or perhaps made yourself. So here's what's important about those preceding slides. The message here is that when we're talking to learners, providing them learning analytics, we need to think carefully about what our communication is meaning to them, what they can understand by it. I can't talk to them like a cognitive psychologist or a sociologist. An easy language to use is the language of the interface that the learners are using in the software that provides the medium for their work. So now let me turn to the software that we developed that's called NStudy, designed to collect, as I mentioned, practically everything that's observable about what learners are doing when they're studying online. Here are some of the key features of this software. And the last main point in italics is essential. Learners are in the driver's seat. They're deciding whether to click buttons and view menus and put text in text boxes and so forth. Those are decisions that they make. And I think we need to not just honor them, but help people become clearer about the bases for those decisions and the options they can have for the decisions they make. NStudy has this dual purpose. And the last point about gathering data refers to two of us that are interested in the data. Me as a learner, and you as learning analysts and learning scientists. That's the dual purpose of this instrument. We're not just a microscope looking at the bacteria on the slide. The bacteria don't care. The learner does. So we want to try to paint as full a picture as possible for both of us about what's going on as I'm learning. So here's a picture of the study space for NStudy. On the left-hand side is NStudy's sidebar, and on the right-hand side is a browser with a pop-up menu. Here's a picture of that pop-up menu. You click and drag across some text and right-click in the Windows world or control-click in the Mac world. You get a menu. The bottom options about creating a term and so on are configurable. You don't have to let people create terms. You can put some other things in that pop-up menu. For instance, a list of note templates, which I'll show you in just a minute. Here's a blow-up of the NStudy sidebar. What you're seeing there is a bookmark at the top called cell division. Then a quote that I've made. They're called quotes because as I drag across that text and say quote, a copy verbatim is put over in my workspace in the NStudy panel. Then there's a term, and I can't read this here. Then there's another quote at the bottom, large one. Here's NStudy's chat interface. Again, the NStudy panel is on the left, and the chat space is on the right. At the bottom, we offer some opportunities for learners to think about how they're going to share information. Literature in computer-supported collaborative learning and small group work shows that people are not naturally excellent collaborators. So as a researcher or an instructor, you can suggest some roles. That's the summarizer, for example, as a drop-down list. You can configure what you want. And for each of those roles, you can give learners some scaffolding about the kinds of prompts that they might use, illustrated in the whatever color blue text that is there. So they click on that text. It's immediately inserted into the text box where the chat begins. The learner can just send that as it is or append some more information if she wishes. Here's a document. We have a little essay or lab or report writing tool where people can construct the material that they want to hand in or share in their group. And then here's a picture of a note template that you can drag and drop over into the document. The idea here is that as you're doing research for a term paper, for example, I like to call it pre-drafting when you're constructing your notes. Then you can drag things over into the document space to begin drafting your essay, and then you can edit that essay to move toward a final product. And here's a view we call all items, listing everything that's available in your NStudy space. There's a blow-up of that so you can see some of it. Learners can select whether they want to look just at bookmarks or notes or a collection of things. They can enter information in that text box up at the top to search for things. You get an indication about how many items are excluded that you've constructed, and an indication as well about how long ago it was that you last used that item. Again, these are configurable features of the software. And here's another note template just to show that you can have a variety of interface widgets there, checkboxes, radio buttons, sliders, date fields, etc. Here's data, just a little bit larger for you to see it. Everything gets recorded with a timestamp, and text that you enter, essentially at the keystroke level, actually a little bit more fine-grained than that, although I'm not sure what half an M or a T really means. And then we have something called the user story, which is a little bit more human-readable account of what's actually going on. I created a note, here's the text I added into the note, then I created a term, then I included the term in the note, so forth and so on. So what do we do with this data? How do we couple it with learning science? How do I make this bridge between the observable activities that the learner uses and talks about their learning in terms of, and what I like to do as a learning scientist? So first I want to introduce this notion that we all use, the idea of a trace. It's a theoretically valuable or useful description. And what a trace should do is describe how I operate on information, what information I operate on, and intrinsically, when I do that, there's evidence that I'm motivated. Behavior is motivated. And we need to remember, as the small insert describes, that the ways in which we examine these traces is infused with our understandings about what learning is. So one word describes the collection of operations, really not completely. This is a kind of 80-20 sort of rule. SMART. I search, I monitor, I assemble, I rehearse, I translate. So this is a very shortened lexicon for speaking cognitively about what learners are doing when they're engaged with information in an end-study interface. Again, it's not complete. No system truly is. But it works for a lot of what we're interested to describe. So let's look at some connections. So when I make a quote, what I'm actually doing is metacognitively monitoring the text that I'm reading for its match to a particular kind of information. Something I think that's important, something I think that might be on the test, something I'm confused about. And why else would I color that information if I didn't plan at some point to review it? Of course, that hypothesis can be checked because we can determine whether the learner goes back to review that information by clicking on it in the end study sidebar to return to the spot in the bookmarked web page or PDF where the quote actually lives. What that activity shows me is that the learner says, I think there's information in the context surrounding the colored text that's in that bookmark. I want to go look there. That's what a trace reveals in connecting the operation I have, an expectation about what information is there, a motivation. I think there's more information that I want to get that I don't have in my mind at the moment, and an operation, clicking on the quote to return to its location in the book. So quoting and annotating using a note template. A template is a web form of some of the kinds I showed you before. Again, those are configurable. If you're interested in argumentation, you can construct debate note forms. If you're interested in explanation, theorizing, control of variable strategies, make the list of whatever you're interested in. You've got a way to help learners be scaffolded in thinking about the slots of those schemas and to record whether learners enter information there and what information they enter and when they do it and in what context they got that information. Copy and paste, same kind of thing. Notice that all of these operations are preceded by monitoring. Monitoring is the trigger for engaging in some kind of operation. Some more. Some of these activities, like in the second one about rehearsing the schema, come along for free in the sense that when the information is displayed for the learner, on the assumption that they actually look it over, and if you did have some additional instrumentation, like eye tracking here, you'd be able to set areas of interest for the titles of each of those slots to see if the learner actually looks at them. But in general, I think you can probably assume that unless these are very long forms, learners get a quick rehearsal just by popping up that template. So in InStudy, you can include one item in another. You can copy and paste it, or cut it and paste it, or drag and drop it. So for example, if I make a note about a technical concept, then I can include a couple of terms, or I can include a Wikipedia article's bookmark in that note. The idea here is I'm constructing larger packages of information, organizing information in ways that I think are going to be useful for me. So what do we do with this data? Well, what do I want to know about me? What we have yet to design next year is a query for the database that's recording all of InStudy's data, so that students can enter their own queries. What notes did I make yesterday that included term X? In what chats did I have with Al about why biology is a silly subject? What can InStudy tell me that I don't know? Human memory is forgetful, biased, and selective. So things that I don't know could be important for me to come to understand about my learning. And then, what can I do with this information about my studying? If I'm making about 1 note a minute, now what? If I'm making lots of quotes that never include the terms that are the disciplinary building blocks of the study, of the subject I'm studying, now what? So again, I'm going to reiterate a little bit of the interface here. How do I talk to myself about my learning? I'm not saying, I'm not rehearsing information enough, I'm not metacognitively monitoring using an appropriate set of standards, I'm not applying the spacing effect by scheduling my review of things. That's not the way I talk to me. I talk to me in terms of, did I create and title a bookmark? Did I make a quote from a text or from a video display? Did I use a particular note template? This is the language that makes sense to me because it's what I'm actually doing in the interface. I also get some support, so you can put this replacement text there to give me some guidance about what I should be thinking about as I'm trying to fill out a form. If you think I'm expert enough, you can leave that out. I think about my confidence, how much effort I'm applying, how well I know something, what the cognitive psych literature calls a judgment of learning. And I think about the options I have, again, in terms of the interface. So here's where that arrow I drew before between understanding what we're trying to understand and the definition of our data comes into play. We need to think about designing traces in ways that make sense to me if you're going to feed back information to me in the form of learning analytics, but that also have for me as a learning scientist some theoretical purchase. Here's some verbs that I apply. These are things, again, that I do. I tag something. I map something. And those couplings between these observations and the theoretical interpretations of them that I was showing before are the bridges between what I do as a learner and what I need to think about becoming as a nascent learning scientist. So again, these are important questions that we need to ask about the reports that we generate for learning analytics. And just like advertising, we're probably going to have to do rather a lot of research to determine how to format these, how to schedule them, how complicated or easy to make them. Just thinking about it as advertising for learning science, if you will. So here are some very basic notions about statistics. Counts, notions about workflow. And the different time periods that those workflows describe. A kind of technical account of what a tendency or a disposition is like in terms of the conditional probability. And then effects. Under the tendencies, I've noted that this collection of conditions is a multivariate structure. Life is not as simple as saying, oh, if I see a bold term, then quote it. Not every bold term gets quoted. Why? So we'll need to try to ferret out, by looking at that information, what the computational linguists and AI people will be able to help me with as a learning scientist, to figure out what is the learner using as a standard for metacognitively monitoring those bold things that get quoted and those bold things that don't. Then, is there some value in revealing that difference to the learner, again in terms that I as a learner can make sense of? So this also is not a particularly new notion, but the idea here is that if you've got a sequence of events, A, B, D, B, C, etc., you can organize these in a transition matrix, start in the row with the first event, put a tally in the column for the event that follows. That event now becomes the identifier for the row, look for the event that follows it. Build out that transition matrix and construct a graph like this. Here's a picture of a learning strategy. What we're interested to do as learning scientists is investigate, is my learning strategy more or less complex or more or less productive than yours? Are our learning strategies nearly congruent in the sense of congruent triangles? And for learners, can we show them pictures like this, not exactly like this, but with words in places of where those letters are, and perhaps some other kind of info viz like weighting the arrows or whatever, so that it makes sense to them to say, oh, this is how I go about, for instance, scanning and quickly running through a chapter. Then how I go about studying it in greater detail. Here's how I review that chapter. What's the difference between the way I scan it and review it? If I bring those two graphs into congruence, is there some benefit? Or if I make them diverge in a particular way, is there some benefit? We can think about the ways in which these kinds of patterns become structured. So what I'm showing here are a couple of features of these kinds of graphs that may or may not turn out to be useful. So for example, there are these green areas, partitions of the graph, that are fundamentally identical. Now they won't be exactly identical because learners are going to react a little differently to different bits of information. And they're not automatons, so they don't do the same kind of assembly line operation every time they engage in a feature. But they may be close enough together that we'd say, yeah, you've got a repetitive pattern here. The pink features show some kind of change in the way that I'm studying. At the early part of the graph, I'm only using one kind of event to lead into the green partition. And later, for some reason, I'm making that a little bit more complicated. Is that an improvement? Is that likely to frustrate me? Those are the kinds of questions that we could ask and potentially feed information back to learners about how they're going about learning. So they could say things like, yeah, it takes me a little bit longer to do the second pink, more complicated workflow, but I find it more satisfying because I think I know what I'm doing. I also want to talk about terms. So since I'm not schooled in artificial intelligence and computational linguistics, I had to step down from what I think is where we want to go in learning analytics to actually try to understand that information to something that's just string matching. So terms are the building blocks of our disciplines. I have a book in my office that's an introductory biology book. It's 1,000 pages, and its glossary has, I haven't actually counted them, but I estimate a little over 800 terms. It seems to me that biology is fundamentally two things: learning an entirely new language and being able to write sentences in that language. So, I agree, that's a gross simplification, and biologists are now starting to feel nauseous or wanting to throw things at me. But can we make use of just the fact that there's a term like mitosis and use that to inform learners about ways that they're studying? So we have some nouns. Here's a list of them that covers a variety of subject areas, and verbs and adjectives. All of these are words that you'd expect learners not to know much about when they start studying a particular subject. And I want to make a very simple statement, again, maybe simplistic is a better word, that meaning is a particular configuration of these nouns and verbs and adjectives. And I want to talk about 3 of them that are very easy to detect. So when you construct a term, you have the term itself, mitosis, and then you have a description of what that term is. If in describing mitosis you use any other term, you have an in terms of relation. This is the dictionary game. I wanted to look up this word, and it uses a word in the definition that it understands, so I have to look up that word, and so on. Here's a graph that shows the ways in which meaning for me is connected. That if I don't understand something that has an in terms of relationship with another term, I need to do more to understand the first thing. Then there's some other things that are very simplistic in text. Under the Gricean assumption that when authors write material, they try to be understandable. If I use 2 terms together in a sentence, some relation is connecting them. I don't necessarily know what that relation is. Computational linguists can do a much better job of that. But I now know that the author says there's something connecting these 2 terms. And I can make a graph of those sentence co-occurrences. I can compare it to the in terms of graph and begin to think about ways in which the in terms of graph isn't capturing whatever the text is describing. I can do a similar thing with paragraphs. There are likely to be a small set of terms in paragraphs. Again, the author is saying these somehow go together. Learner, you have to figure out what that relationship is. So, I guess I should have said before I went to that slide is, can we invite learners to think a little bit more thoroughly about the building blocks of what they're studying just by showing them these kinds of pictures? And again, maybe applying some info bits. So you could have node diameter, for example, showing the number of times I've operated on a particular term on the assumption that the number of times I operate on something is likely to increase its retrievability. Old finding, Ebbinghaus. Or the weights showed by thickness of lines indicating, for example, the frequency of sentence co-occurrence, saying these 2 things are really coupled together. These other things that have a line pixel weight of only 1, yeah, they occur once together, but maybe not so critical to get in some kind of connection. There's something I might act on as a learner, but you'll have to help me figure out what I should do in looking at those kinds of pictures. So now let's turn to actionable analytics. And remember, I'm doing the studying here. And so, let me just go back. The little symbol I've got there is the best I can find as a target. These are some things that I think, and I might be wrong because this is not my area of expertise, that we might want to work towards in learning analytics. So I carry out operations, and we can easily determine the frequency with which I do a particular operation, what type of operation it is, and I've just described some ways in which we can begin to examine some patterns of them. So if you want to monitor me to, or nudge me to monitor differently, here are some things you might do. The target, how do I, given a text, as a learner, get some information about what I might be monitoring about that text other than, I don't understand it. Are there particular kinds of things I should be looking for? Relationships, conceptual structures, or schemas? So for example, could we build a classifier that would go through text and say, this paragraph is presenting evidence for an argument? You don't have to tell what the argument is, you just need to be able to identify something about the semantic and syntactic structures that say, yeah, that's an argument. This, I think, has been done. So here I am viewing things. So related to information that I viewed previously, this is easily done through a term map where the in terms of relationship is connected. Show me the paragraphs that include the term that's connected to something that I'm looking at the moment. Here I am generating text. So if there's a term that's in terms of related to another term, and I'm using one of those terms in a title, remind me about the other term. Expand my thinking about, okay, I just used this term in my title. It's defined in terms of, or the other term is defined in terms of what I just put in my title. What am I not thinking about that I might be thinking about to rehearse the structure of the discipline in which I'm working? So in short, what I'm suggesting is that we nudge people, in the sense of that nice little book, up toward thinking about, what am I doing? How can I extend the information that I'm working with in ways that correspond to the structure of a term net, a sentence co-occurrence net, a paragraph co-occurrence net, some fusion of those? Can you help me identify features of text that I'm not operating on enough? I would say attending to, assembling, and so on. So again, recommend using a note template. Can we identify a classifier that says, this web page is fundamentally an argument? You need to be looking for, what's the claim? What's the evidence or set of evidences that are provided for that claim? What are the warrants that make that evidence appropriate for the claim? Just showing me that schema, that note template, might scaffold me to think, I need to change the detectors I was going to use in metacognitively monitoring this. The target about patterns of operation, again, I think this is relatively doable. This is a major issue that was discovered in the research in the 1980s about reading comprehension. It was not difficult to teach elementary and middle school students to use reading comprehension strategies. What was difficult was to get them to continue using them when they were released to the classroom with things that weren't part of the training materials. So can we remind people about, this text has a certain structure, and previously used this kind of approach to study that kind of material. You think it worked well? Why don't you try it again? You might be able to improve on just whether I thought it worked well. I'll tell you that in a second. And again, here's translating. So, part of the definition of learning analytics at Solar's website had to do with optimizing learning and learning environments. So a few more targets. So I'll just mention about the fourth bullet there, translating information. So you see the term in the text, quadratic. Okay, quadratic. What's that mean? Well, the graph affords you some very useful information that you may not, if you're not intrinsically a mathematician, realize. A quadratic expression has a point of inflection. The sign of the coefficient tells you whether it's oriented this way, or that way, or this way, or that way. Do I remember those things when I see quadratic expressed in the text? If I'm talking about physics and scales, do I realize that the shape of the curve that a logarithm refers to? So when I'm talking about decibels, do I understand what that scale means? These are things that we could suggest to learners based on very simple techniques that we have available to us today. The idea being, as a learner, I should up my detection. When I see an expression that refers to some mathematical construction, can I make a picture of it? And does the picture afford some meaning that I'm not getting from the text alone? The second bullet at the top about learning objectives is really important. My colleague Alison Haddon at the University of Victoria has a Learning to Learn course, or learning skills course, that she teaches to a collection of first-year students across the campus of the University of Victoria. So I'm almost at the end. Just a couple of points that I want to make. So the idea here is, part of my complaint about RCTs is that the mean is a statistical construction that doesn't really apply to anyone. You might say, well, what about the person who scores exactly at that mean? Well, that mean, statistically speaking, ignores all of the moderator variables that give the normal distribution its shape. And that person who scores at that mean has a particular profile of those moderator variables. It isn't necessarily the case that those moderator variables don't matter for that person. So my proposed solution to this is, let's use all those moderator variables, but not just the demographics. Let's use as moderator variables the ways in which people are working with the information as they study it, and characteristics of the information they operate on. Let's construct a model of how I study what I study, and use that in a post hoc fashion to identify a group of learners, like in the middle group here, who are just like me, except for maybe one thing. They're working faster, they're a little more satisfied, they're scoring a little higher, whatever the case is. Now you have the basis for suggesting to me taking into account all of those moderator variables that are washed out in RCTs. It says, here's something I might nudge you toward. Just display the whole thing. So here's my objective. As a self-regulating learner, I'm interested in finding out how I learn and how I can learn better, whatever better means to me. To do that, I need to be a learning scientist. If we work together in partnership, sharing data, sharing explanations, I theorize that we can help one another better understand how learning happens, and me be a better learner. Thank you. Questions, complaints?
I assume I need the microphone.
This is April Galliard, University of Georgia. Just looking at the in-study tool that you put together, it seems very dedicated to learning declarative knowledge. And what adaptations do you think would be necessary to help scaffold students learning more procedural knowledge, engineering, physics, statistics?
So in the browser panel, anything that's on the internet, you can work with there. So for instance, if you have some simulations where in the browser side you're fixing values and parameters about, for instance, pendulum motion or an ecological system, etc., and your simulation is recording those, sync those up with the stuff that they might be reading in preparation for the simulation, or show them the table that they, record the table that they make of the simulation, showing the values that they graph. Have them examine that table just like they would a text. Select it, you can quote it, record where it comes from, So the possibility for looking at procedural activities, for instance, making computations, doing analyses of systems is available. Is that what you're intending? What kind of procedures are you talking about?
Well, I'm thinking more of, well, I teach an intro stats class, and so a lot of that, you know, they're doing the analysis in SPSS, and you know, there is a lot of declarative knowledge they need to know, but where they get stuck often is in, you know, interpreting a graph or making the graph in the first place.
So I'll give you a favorite example. I teach a multivariate stat course. You know what I start with? Fractions. The reason I start with fractions is that most people don't realize that the denominator of a fraction is the unit for your ruler in inferential statistical tests. So they're thinking about, okay, I've got a pie chart and I've got, you know, like 3 things at the top, but the whole thing is measured in 4. The idea is that you want to give them a sense about what the effect size is for a statistic. So that's something you could describe in text. You could describe it as a figure. Begin to introduce those kinds of notions. I let all the computations be done in JUMP or SPSS or whatever piece of software you like. I mean, when I was a graduate student, this is really going to date me, we got away from hand-crank Monroe calculators to an actual electronic calculator that had a memory. Wow, was that an advance? And as some of you may know about the history of statistics, the reason that the ANOVA model became so popular was because it was hand computable, whereas matrix inversion prevented using the regression model, which is actually the parent of the ANOVA model. Let all that calculation stuff happen as a magic black box, unless you really think it's important for people to know about matrix manipulations. And teach the concepts like the fraction is. That, I think, is eminently doable in a thing like N-study, but you might have to collaborate to figure out how to make it work for you.
I'm Tiffany Barnes. I'm giving the keynote tomorrow morning, and I just wanted to respond and say I think we need to instrument the steps of procedural learning very similarly to how you've instrumented the steps of sort of declarative learning, and I'll be talking about that tomorrow.
So there's your answer.
All right.
Or there will be your answer.
Regina Collins, New Jersey Institute of Technology. So is there any assessment type of component? So in other words, you know, I may think I'm learning, I may think I understand the material, and when I go and take the test, I may do really poorly because I missed something or I didn't have all the nuances of it. So is there any way that you kind of judge the quality of what the students are doing?
Sure. You can either use a completely separate service. So in Canada, I use Fluid Survey, which lets you put together any kind of test or survey you're interested to do. We also have our own in-house one that we're working on so that an instructor or a researcher could develop a test. One of the things I'm kind of interested to do is see if I can nudge people toward thinking about what they quote, how they highlight, is, and which we now are able to do, is represent the web page with blanks where the quotes are, a closed test as it's called in the literature, and say, okay, so what goes here? The idea being that what people need to pay attention to when they're filling in these blanks, when there's words surrounding them in a closed test, is context. So yes, it's possible to coordinate that, provide scoring, give feedback of the achievement varieties, and then connect it up with the kinds of things I talked about.
I'm Annie Mustafa, Wellesley College. Zach yesterday was talking about emotional states at some point, being bored, confused, frustrated, and how that relates to learning. I wonder whether emotional states are something that you can use to annotate your process here, or have you thought about that?
Yeah, so if you have other instrumentation that you want to use, you know, butt sensors, eye track, GSR, etc., sync all that data, put it together, make up an even bigger multivariate profile of me and my peers. But I'll tell you an interesting thing about motivation. A student and I, in her dissertation, Ming Zhou is her name, looked at the issue about self-report instruments. So what we did is we constructed a text that had some hyperlinks in it. And we also allowed learners to tag things. The hyperlinks were expressed something like Click here for interesting details. Click here for information that will be on the test. Interesting details, mastery orientation. Information on the test, performance orientation. We had people fill out a survey in the LA's called Item Achievement Goal Questionnaire before, and we traced what they clicked. Interesting things. Behavior didn't match what they self-report. Self-report didn't do as good a job of predicting achievement as what they clicked. You might say, oh, well, that's easy, because when they click things, they go to different places. Actually, the information at the destination for both those links was identical. The point being that what people describe about themselves is a statistical average of some distorted sort. What they do in the moment with context was different. And what they did in the moment with context mattered more than the statistical average. The same thing may be a bit true about emotions, but we don't know. At present, when we ask people to describe, when you study statistics, do you get anxious? When you work on a problem for 20 minutes and you're not getting the answer, do you get frustrated? You saw yesterday that sometimes frustration is a good thing. People typically, however, tend to interpret it as a bad thing. What's the real story? You have yet to find out. Anyway, you can match up NStudy's database, the log that's in the database, with any other instrumentation you want.
Thank you for your speech. I think one of the central arguments that you made is regarding the average level for whole population, where a lot of learning scientists are focusing on, versus individual learner. And my question is, that might be a naive one, but what if, like, for a given population, does it ever happen that the average level is the closest to the optimal level, and the students, as individuals, wanted to achieve the average level, or some of the part of the population, students saying that, say, they're not there yet to be fully, self-regulated, and then there's a medium stage they wanted to get to before they reach the fully, individualized learning style.
There are some cases you can imagine where something that would be in an average along the scale might be better. The inverted U-curve for arousal or anxiety is an example, where you probably want to be at the optimum level rather than the completely bored or the so anxious you can't pay attention to anything but your anxiety stage. But these are questions to be investigated. What's the spread of the distribution? What's the nature of this multivariate profile of moderated variables? Is average the right sense to think about it, or is it more like fit of one model to another model?
Hello. Hi, I'm Andy from King's College London. I've got 3 questions, so bear with me. Do you think it's a limitation and restriction of your tool that it's only about online text-based resources?
Yes.
There's no. Yeah. Okay. Do you need to elaborate, or is it?
What more is there?
Do you have any future plans for like video, audio resources, experiences?
You can use video or audio. You get there's a video pane with a scrub line. You stop it, and then you we call it command click, so you don't have to keep saying right click or command to bring up the menu. And then you don't actually get the quote, although I imagine somebody will have voice recognition that works for any arbitrary video eventually, so we'll actually be able to get the quote in text form. So you can use video and audio resources, and as I was saying, whatever was over here, about simulations, where that, again, if you sync up the data the simulation is recording with the data the demonstrator records, you can begin to put those things together in a larger picture.
Okay, excellent, thanks. I'm not sure if I got this correctly, but the recommended actions to the learner are actually based on the previous actions?
Not necessarily. You might want to be testing the theory. So I described the case where I'm just studying online because I'm interested in something, or I have an assignment like a term paper to write. But you can use NStudy as an instrument in regular RCTs if that's what you want to do as well.
Do you think there's any usefulness in recommendations from, obviously not maybe the average student, or maybe top students? Do you think there's any usefulness to that?
Something to explore. And I want to reiterate, I don't want to throw away all of the literature that we've generated based on RCTs and approximations to them. But it's a place to start. The idea is, can we tailor those findings in productive ways and divergent ways to match individual learners who aren't right at that average, given that I'm not satisfied in saying a person is at the average in the first place.
And last question, because I'm holding the mic here. So do you think, because you said that the learners don't really set goals, they just open a book to a chapter and start reading. So do you think the learner is the most appropriate person to actually set a learning goal? Isn't that the job with a tutor, or maybe a characteristic or a really useful resource to set the goals at the beginning?
Both cases are true. So if you're in my EdSci class or my STAT class, I'm setting some goals for you. Guaranteed, you should be setting some of your own goals. When you're working on a project like in a history course, write a paper. How much more direction is typically provided by the professor or the teacher? The student has goals to set for him or herself, so they need to learn about goal setting as well. So it's a mixture of both kinds of things. We work in environments that have constraints and affordances, so there are goals that are available to us. We also have our own.
Thanks, that's great.
Right, wrap it up there. It's a very good time. And it's time for a break. So I'm sure Phil will be around.
Yes, I will. Thanks very much.